talking about some basic things we've got on machines which people tend to ignore. So we'll start here. Safety and working environment. Sweden, I can go from our experience here. We have roughly 300 traffic accidents a year where we get injuries or even deaths. And Europe as a whole has roughly 10,000. And if you're wondering what it says in the picture on the right, it says "Tack för att du hjälper mig komma hem." It says "Thanks for helping me to come home." So it's a very, very big focus in Sweden. The Swedish Road Authority has what they call zero vision. They're always aiming to reduce accidents to zero. So they spend an awful lot of money to get to this. But it is a huge problem in the road industry, especially cars, motorists who really don't pay attention. I can't really say from look at the UK and saying how you're managing it there. But here we spend an awful lot of money on these heavy trucks with energy absorption devices on the back. It's one of the biggest costs in the paving job today, having these kind of vehicles around. So we have a lot of discussions in industry regarding safety, especially agencies, local authorities saying what they want. This is a high priority. Again, it's the same in most countries. Some of the East European countries, I don't offend anybody, it has a lower priority. But we're developing many new digital systems. As I said, people object detection, autonomous machines, it's all coming and it will come. It's unavoidable. The problem we have, though, is people are always looking ahead to what's coming next instead of focusing on a little bit. Yeah, it's good to focus what's coming, but also focus on now. What do we have? What are the things we don't actually use? We have options available for a lot of machines that can dramatically increase safety. But many times they're ignored, and partially probably it's the fault of the industry that we don't market the safety aspects in the right way. But many times it's because of cost. We see this is an expensive option, we won't buy that on the machine. Yet it can have a huge effect on the safety on site, at least the safety, mostly it's safety for the workers. We'll start with paving. We're going to run through paving, some standard options and some more advanced options. Then we'll have a look at compaction. And then I got a little extra task the other day, so we'll do a little bit on quarries. This isn't my area anymore, but I think I pulled out some interesting things on quarries as well. So we start with the paver, and we start with the simple equipment that people don't use or don't buy. Hydraulic Endgates on a screed. Makes life easier if you're looking at from ergonomics, and the guys, he doesn't have to wind the handle to, now he has a hydraulic adjustable thing, so he can adjust the end plates. And this not only helps, it helps to improve the quality of the pavement as well, because he has an easy control. He can move these up and down to get maximum compaction from the screed, create good edges. But the safety aspect that people miss is that we move the people. When we have these hydraulic Endgates, we move the people behind the machine. They don't have to stand to the side of the machine. They're out from the traffic. And this is a huge, a lot of the accidents it's happened to me myself. You take one step back and you've got traffic, half a meter away from you. It's so easy. But if you keep the guys focused forward, they have access to the control panel behind the machine. They get full protection from the machine. They're only exposed from behind. And this is one of these things that when we're discussing tenders with customers, you talk about this, that's an expensive option. We probably don't need it. But it should almost be mandatory when you look at it, because it really moves the people off the road, basically, away from the traffic. So this is this kind of thing, when you think about it, it can sound like an expensive option. Then when you lift up the safety aspect, you suddenly realize this is a very, very important safety detail on a machine, which should really be almost standard. I made a short film. We're very good in Volvo at making short films. We've made a series of videos called On Site, 30 seconds. So I've actually put one of these on here just to show you. I hate seeing myself. So this video was made last year, and it's a 30-second video, just we tried to time it right with traffic. So here comes this short video.
Have you ever thought about things that can make paving easier and better? Our new hydraulic Endgates, which are available on most of our screeds, do this. They also improve safety in one of the areas where the screed operator is most exposed: traffic.
They're very simple, effective videos. We have people here. We actually film a lot of them with mobile phones, and just do. Now we do a small film about this. Took a bit of timing to get the truck right, but it's just to effectively get the message over of a certain aspect of the machine. And I think that one, I quite like that one, but not because I'm in it myself. I hate that, but it really does put the message home. You're standing behind the machine. This is the problem: traffic coming past you. The next one we've got is hydraulic front apron. Again, it's an option on a lot of machines. You have to pay extra. Some people take it, some people don't. And all it's there, it just helps to stop material from falling in front of the paver. You can lift it, you can push the material back. And the big safety advantage is this. You have spilled some material. The guys have to go in front of the machine many times, shovel it up, and they're exposed. There was an accident in the UK, I think, 1 or 2 years ago, where a guy was actually run over and killed by the paver. This is why you have I think in the UK today, you have the traction control. I think it's traction, well, not traction, was it drive control? You can actually stop when you're working in the front of the machine. You have a safety switch to actually cut the drive to the machine. But it's a very simple thing. Again, it helps. It doesn't eliminate the problem, but it helps to reduce the problem that people have to go in front of the machine, especially if there's trucks nearby as well. They're backing into the paver. So, let's see if we get this one. Yep. Then we come to small stupid ones. Heated seats. Scandinavia is a colder country. This is like a standard option. And it really does improve safety. The guy on the top of a paver in October, November, it's not ideal conditions for paving. He's generally sitting still quite a lot. So this improves his physical condition while he's sitting there. And it's not just a luxury. It really is a necessary. It's a hell of a place to be on a paver in October when it's blowing. You don't get that much heat from the asphalt under you. So simple things. Yeah, people think, it's a lux, we don't need that. But think carefully. It improves productivity. It makes the guy more aware, not huddling up because he's freezing. Then the other obvious one, 360 cameras. We're not going any further into that. Everybody knows the benefits of 360 cameras. A lot of people do buy them. And these will be combined in the future when we come into people and object detection. Now we're getting to the more advanced solutions. So I'm trying not to make this into a marketing thing for Volvo. Is trying to be neutral, but we're going to be talking about these a little bit further ahead. So on all of our machines, we have what we call the assist products. So soil compactors and asphalt compactors, we have compact assist. On the pavers, we have pave assist. And this is the basis. The Volvo Copilot in the middle is the basic screen we have on all the machines. And then we have different apps, basically, to run different functions. And then you can change functions when new functions come. So it's a living tool. You can always upgrade it. And these also connect to each other. But the Copilot, we call it the Copilot, is the basis for a lot of the systems I'm going to talk about shortly. So, if we're into pavers, an asphalt paving manager or pavement management system, here we can get automatic ticket transfer from the mixing plant, or if a truck has had it, we can get he probably has a smart app on his phone. He can transfer the ticket automatically to the paver, so it's registered on the paver. As soon as the truck, in the UK, I think it's generally that you have the banksman, a guy who's running around the paver, going in between the truck and the paver, exposed to quite a high-risk situation all the time, that he's always going to be somewhere around moving machines. But anybody here is a banksman. We're not trying to do you out of a job. This is just pushing technology forward. That we can do today. We can take automatically tickets from the plant. We can send them directly to the paver. The paver will store them until the truck arrives. And this reduces this high risk situation that people are, in the heat of the moment, maybe 5 or 6 trucks are arrived, you forget, and you walk in between the paver and the truck, and that's it. So this is a very simple thing on these pavement management systems, just to transfer the ticket order, but you remove this risk, site risk. We're talking about these systems. If you see this picture on the right, you can see that we get a complete, all the time we can see how many meters we've paved, how many square meters are paved, our paving speed. Now, it's a ridiculous paving speed here, so don't pay any attention to that, the figure. And this isn't the most up-to-date actually screenshot. The average width we've paved, but we get an exact, and we know it's exact. It's an exact figure of what the paver has put out, how many square meters it's paved. So at the end of the day, nobody needs to go back and measure the job. And we see it from an economical point angle. It's usually saves on a bigger job. It saves an hour of work every day at least. Yeah, you have a document there as well. The system can create a report, which in turn also reduces stress for the other guys who are actually managing the job. These reports, it's a final quality report. It's a quantity report for the job that was done that day, and they can get that directly from the machine. It can be sent to the cloud. They can fetch it. They don't need to visit the site. All the kind of work that's needed to put together this kind of report. But the big thing is, of course, that you remove the people from going onto the site after they finish paving, where there's no protection from vehicles, that they can actually measure the whole job. And again, this is we're seeing it now as becoming more and more a demand on the machines. We see the teams that have these systems on the machines today. It becomes almost a catastrophe if they break down. It's become an essential part of their kind of equipment on the machine. But it's a big thing in here is that, again, you remove the person from the road. He doesn't have to go out. It's usually dark. It's the end of the day. Again, the machines are gone. He's got no protection from anything. He has to walk down the road with a measuring wheel, measure the width here and there. And also it saves money because you're reducing the number of working hours. Everybody's listening. It's very difficult talking to a computer screen. So have some understanding. You need to see feedback, and you don't get it. Another thing we're doing with this paving system, the same, based on this Volvo co-pilot we showed before, that from beginning of next year, all our pavers will be connected to the cloud. And we have the ability, at least it'll be tested in Scandinavia, we'll have the ability to send information between trucks, cars, from the paver to trucks and cars, telling them that there is a roadworks ahead, and they'll get this probably about 2 or 3 miles before they reach the site, and they will get information. It will come up in the screen. I'll show you the next one. So they will get, when Volvo Cars will be the first to do this. Although Volvo Cars is probably is not part of Volvo Group today. We only share the brand name. Volvo Cars is actually a Chinese-owned company based in Sweden, but we do share a lot of things. So 2020, and what will happen is they will get in the instrument panel. It will come up roadwork ahead. Drive cautiously. So this is one of the things we're pushing for now. Initially, it's only going to be on Volvo vehicles while we test it. But then we're looking at third party, putting onto other vehicles as well. I think BMW and Mercedes are also testing a similar thing in Europe. So this is what's coming. And you have the co-pilot. It has the ability to generate this information, to send it out. This is an old film. I think I've seen it before. But actually, I've listened to the text on a bit more, and it is actually a very good film, and I thought here we needed a bit of extra material, so I put this in. This was done in 2007 by Volvo, and the idea was just to show a futuristic idea for a paver. And when you listen about fuel cells and things, it was actually on the button what probably is needed, but it's about 5 minutes long when it goes. And see what you think.
This is Phoenix, the extreme concept asphalt paver compactor from Volvo Construction Equipment. The Volvo brands of ABG and Blore Knox have built unshakable reputations for quality and innovation since the early days of mechanized asphalt paving in the 1930s. But no one has ever seen the like of Phoenix before. Like the immortal mythical fiery bird that is its namesake, the Phoenix paver excels when the going gets hot. Not only is it fast, flexible and intelligent, it's clean, easy to use and friendly on the environment. While clearly a Volvo, it's almost unrecognizable as a paver. Phoenix radically redraws the traditional profile. In fact, it's much more than just a paver. It's a fully integrated highway paving finishing system. Looking like an earthbound lunar landing craft, Phoenix is a unique creature. Unlike traditional pavers, whose progress is entirely dependent on the sometimes erratic arrival of hot asphalt-filled trucks, Phoenix instead uses Volvo's ingenious pod system. The pods are laid out in front of the approaching Phoenix at predetermined spaces. Each super-insulated unit filled with 17 tons of asphalt mix, made from environmentally friendly, quick-curing organic binder. Once emptied of its asphalt, each super lightweight pod collapses automatically into a space-saving compact size, ready for return and recycling to the mixing plant. The operator of the future will no longer be exposed to the elements and will board Phoenix by using the inclined ramp. Once safely seated in air-conditioned comfort, the entire cab can be elevated to give a commanding worksite overview. The cab position can also be altered in height and aspect to suit the needs of the job. Phoenix is now ready to pave. An onboard digital interface allows Phoenix to communicate remotely with the mixing plant and pod haulers, telling them the precise location on the road to place each pod. The operator is then notified of their arrival by a radio frequency identification device fitted to each unit. Pods glide up Phoenix's front loading ramp onto its conveyor system. While this is happening, another pod is discharging its load into the hopper in a seamless, continuous motion. Empty pods are gently deposited via a discharge ramp onto the rapidly cured finished pavement behind. And thanks to the almost silent hydrogen fuel cell drive system, all this happens with the minimum of noise, fumes, or fuss. Once fully loaded, Phoenix's slat conveyors move the paving mix into its auger chamber. Variable pitch, speed, and width radial flights distribute the mix laterally to the exact paving width needed, just ahead of Volvo's revolutionary high-density triple-width screed. Data is collected from operating systems in real time, and a heads-up display shows all critical operating information, such as forward speed, paving width, laydown thickness, and relative density across the pavement. Integrated solar-powered arrow boards and reflective striping on the rear panel of each pod shine out, warning road users of their presence and assisting with active work zone safety. Cleverly, Phoenix is also able to paint the road markings as it goes along, allowing traffic to flow immediately once the site is cleared of empty pods. In line with Volvo's core value of environmental care, paving with the Phoenix system incorporates many green technologies, not least the total elimination of emissions or fumes. Large-scale recycling using the Volvo pod system is also a key element of every project. Phoenix may look fantastically futuristic, but its design features are deeply rooted in real engineering potential. Many of the ideas contained in Phoenix are destined to become regular features of road equipment in the decades to come. Phoenix, smooth when the going gets hot.
Good. Many of you may have seen that already. It's been on YouTube a long time, but it's well, my thing won't work anymore. Yeah. Okay, that was a bit about paving. I thought we'd finish off with that video. It was quite a lot of it still holds. Just to add that we don't own Blore Knox anymore. We actually sold it a few months ago in the US. But I think the only thing that I would say is probably not right today is probably there won't be an operator on the paver in the future. We're still on the operator there, but looking in the future, maybe he'll be somewhere else. Right, compaction. Little kind of futuristic picture I've shown before. Some people have seen that in the future, this is a concept machine we actually built. I don't think it'll ever come into be reality, but it's kind of your operator won't be on the machine. But I think we've gone beyond that anyway. I think compactors will be autonomous in the not too distant future. It's probably the first machine that will be fully autonomous because it just has to follow the paver. The danger is that you have to be very sure about the safety aspects, and that's where I think most of the autonomous systems fall down. Still, we still haven't got, and we can't stop people wandering into the site without causing catastrophic failure, like suddenly the paver stops, the roller stops, and you're standing on hot asphalt. So these things have to be sorted. But looking now, I hope we get a bit of a discussion on this today, that safety and working environment, compaction monitoring, intelligent compaction. These systems aren't new. They've been around quite a few years. Of course, they're far more advanced now. The actual computing is completely different to what it was for 10 years ago. But still, and despite that we cover 100% of the surface, that we measure everything, passes, temperatures, we can even measure, with our system, we can even measure level of compaction. So, and from the experience we've got in the US with the system, we see that we have an accuracy on average of about plus minus 1.5% on voids. Yeah, so and this is using a neural network. The machine basically teaches itself. But from a safety angle, we still use destructive testing. We still take cores. And the question here, if there's anybody in Highways England or Authority, why? Why do we still take cores? When all we see is 0.01, it's actually 0.0001% of the surface we actually test. That's the only information we have. These systems give us a picture of the whole surface. And doing a good statistical analysis, we can actually get out valuable. We could approve a job quite easily. And here from the safety area, we can remove, I think you've heard this earlier in the week, we can remove people from the road. There's no need to do all this testing. You can do a calibration area before you start the job if you want to calibrate against cores. But the system itself, they're accurate enough, they're reliable enough, and they produce so much information. You have there's no other way of getting this level of information. And then the operator himself, using this kind of system, suddenly the operator gets a tool which improves his, psychologically, it improves his working day. He actually has something to work towards. He's not just, did I finish there? Did I finish? It takes away the uncertainty. He has a clear picture of what he's done, where he's been, that he's done as is required. So it's two things. We can, by using these systems, we can remove people from the road completely, and we improve the operator situation as long as we have an operator in a roller. Yeah, again, these will become autonomous in the future. I don't think we're really there yet, but at some point we will be there. People object detection. And again, all these systems, again, we go back to that first picture, at least from a Volvo, the Volvo Copilot. All these systems were based on this computer that we have in the cab. So everything we do, and we're expanding this all the time, different features you can have. The next one that will come next year will be people and object detection. The different variants we can have, how you want to display. The first picture you see on the left is that you will have basically a moving bubble around the machine. So you will continually see what's happening around the machine. The other picture is where it will light up when something comes near to the machine. So it grabs your attention. And these are being tested now. And I think there are already some on the market. And this is a big step towards autonomous machines. It's halfway. Once we start getting this and then scaling the machine to learn itself how to use this information, that we will improve safety. But these are coming requests. But again, think again what we already have. This is another level of protection than the compaction system. But the compaction system first is something we should look at more. The US has basically standardized on these systems. You cannot do asphalt with a highway authority in the US if you don't have a compaction system on a roller, not from a safety, from a quality angle, but they also remove a lot of people from the road. There's nowhere near as much work done on the highway as there was before. One of these small comments, idiotic ones, I thought I'd throw in, just like the heated seats. air conditioning in the cab. This one's a bit. This was taken in Finland a couple of years ago. We were 3 people in the cab on that machine, so it was actually necessary to have air conditioning. It was ridiculous. But if we go to if we compare to the US, I can't say exactly how it is in the UK, but in the US, they don't even fit a cab. They don't value the operator on the roller. He gets no attention at all. They don't even fit a cab to the machine. But we see now that, of course, AC in a cab should be standard for everybody, at least in Europe. It should never even be discussed. And this is one of these things that people do choose not to take. And you wonder why, because it improves the operator's environment, it improves his efficiency, and it improves his productivity. You can measure these things. So, people should get away from the fact it's a luxury. It's not a luxury. It's actually a necessity on this kind of job. And we have this technology, so why not use it? And it's not an expensive kind of option to have on a machine. Right, moving a little bit into quarrying. Bit of a picture of a quarrying site. This is going to be a digital. So I took this on as a little bit extra. So this is more of a digital approach to things we've been doing. We're going to start looking at implementing 5G technology. We actually have our own, near where I am here, we actually built our own site with 5G masts, everything. So we can test. I'll show the picture, next picture. This is our test site, a little cartoon type picture of it. But here we've tested 5G, we've tested all the electric dumpers. The truck you see here is also electrically powered. The wheel loader is a hybrid. This was actually electrically powered, this one. And this whole site was run basically autonomously using 5G technology. We've had projects going on with universities in Sweden, with Skanska, where we've had common projects, running a completely electric site with 5G communication. But last year we implemented 5G at a mine in the north of Sweden. It'll take a while. This will be mostly film material I'm going to show here. There is a presentation in a minute. But in the north of Sweden, we've implemented 5G. Sorry, I didn't stop a second. And the idea here was to basically remotely operate the machines down in the mine. So using 5G, we have a wheel loader in the mine, which is completely remote. It's driven by a guy sitting in the office on the surface. And the efficiency, as I've heard, increased by almost 10%. He was more efficient sitting on the surface driving the machine. This is just a 1-minute little video. I just thought to show you, it's comments, it's in English, so from the guys on the project.
This 5G initiative is a result of a long collaboration together with Ericsson and Telia. When teleoperated machines are available, it will give the customers the opportunity to move the operators out of their working area. There are a lot of dangerous jobs in mining, etc., that we can do a lot safer by moving the operator to another location. I'm very excited about working in this project. We are on the edge of technology and testing what is possible. And now we will have the best possible connectivity available on our backyard.
Okay, that was a very simple one. But it's real, they were running the whole mine for almost half a year with autonomous machines, remotely controlled machines. And they had an increase in productivity. You could see that machine there. He was loading. The guy was sitting somewhere else in an office driving the machine. He's got full screens around him. And it was interesting that there are some bigger, longer videos on YouTube showing this in more detail. But it was just a bit of a taste to see. So these things are going ahead, and then for us, they're moving so fast. We can't keep up. Things are changing so fast. So back to the co-pilot on the dumpers or articulated haulers. We have a product we call MAP. And apologies again, there's a presentation after this, a short video just showing the system in action. And we'll go into a bit of a presentation after that. So. Good. Hope everyone enjoyed that. This is one of obviously a strong points, making good videos. But I mean, the map system is basically a site logistic tool. You can introduce speed limits. You can introduce when you have road narrowing, dump zones, dump sites. Everybody has an awareness of where each machine is, so they can act in time. And again, this has been adopted, as I understand, for the HS2 project. So it will be used on that. A lot of text in here, but if anybody wants to, so I can make this presentation, or it'll be online, I can make the presentation available later also as well. So I use this 3G or 4G, so it's dependent on having good reception on the site. And it works together, of course, with the onboard weighing system as well. So we can trace quantities as well, where material was tipped, which quality material is there, if it was tipped in the wrong place. So all this is logged, so everything is there. And then the operator gets all this information as well. So he has all the on speeds. He can also introduce his own speed limits. If something happens on the site, they can make changes. There's the restrictions. So it needs GPS and GSM connectivity. You need, of course, 2 machines on site. So anything that isn't a Volvo won't be visible on site at the moment, but that is ongoing. And what you can create on the map, you can create haul roads, you can create these dump zones, loading zones. So you can create restricted areas where there's only room for one vehicle. So you can introduce speed limits, and again, the operator has the ability to change things. If an accident happens for some reason, they can actually go in and make changes. They can bring in points of interest. For example, if you have new drivers, they'll show where the fueling depot is, where they can eat. All these things can be put onto the map itself. So what the operator can see, he can go from a map view, he can change to a rear camera, or he can change to onboard weighing, or he can get a view of his productivity for the day. So everything there is visible to him in the machine. There's nothing that's hidden from the operator. The map view will be like that. He'll see the loading zone, he'll see the dump zone, and he'll see where the other machines are in the cycle. So they can adjust the speed as well. Or if they're too near each other, they can reduce speed to increase distance again. Here's the ability to go in on the map. If they decide they need a new dumping point, they can actually put it in themselves. So all the others are aware there's a new dumping zone here. But the safety aspect, all the time, they're all aware of speed limits and restrictions around the site and where the other machines are in relation to them. Load dump zones again. This is just a run through. So here he would see that you've got this, he's come around the corner and there is a vehicle on the way, so he'd get this information directly in his screen. Speed limits. different points of interest they can put onto the map. Traffic signs can be introduced as well. If they need to divert, people can introduce a traffic sign to guide vehicles. This system is, I say, it's in its infancy. But it's been tested quite a lot in the UK. Then we got productivity. We know where they're loaded, where they're offloaded. We know the quantities. And then we can upgrade the system. You can have, instead of just a blank background, you can bring in actually a map if you need to. Warns if you've tipped your material in the wrong zone. The operator will get it directly, the warning that it was the wrong place. And then you get the productivity reports where we can actually analyse how things were done. That if it was tipped in, how much was tipped in the right place, how much tipped in the wrong place, fuel consumption, travelling back, everything that happens on site is available as a report at the end of the day. But the beauty is it is a logistic system to manage the vehicles on the site, and that part of it is they create the route themselves. When they drive the route, you create the route from the beginning, and then they put in their own limitations depending on if they see the need for speed restrictions or if something happens on site. I think from the safety, it's the speed limit notifications and warnings about problems on site. It's just repetition, but this is basically you'll see more of it now because it'll be standard on all our dumpers now from now. So any dumper you buy today will have this. So it won't have this. You can upgrade to the system, but you'll have the Copilot, so you can actually install the system. Right, and this is the last slide from me. This is a futuristic product done together. This is actually a Lego model, and this was designed by children. This is the future with the engineers that designed this machine. So thank you for listening. It is difficult, I have to admit, speaking to nobody. But the good thing is I can see a few faces here, so at least you get some kind of reaction. So,
Martyn, thank you for that.
Was it interesting? I hope it was interesting.
Oh, absolutely. I mean, it's changed unbelievably since I was sticking temperature probes in the paver over the side of a paver. Yeah, so yeah. Most of those things are welcome and obviously beneficial to all our safety. Can I kick one off? If you're doing compaction testing, could you do textured Epson profile too from the roller?
You mean the profile of the finished pavement?
Yeah.
We've discussed that recently, actually. In another, I've always, for me, because everybody talks about the paver, and in my world, it's actually it's the roller doing the finishing. Who actually, he's the only one who sees the finished pavement, and we've been discussing scanning from the roof of the roller to scan the final profile, so you get this information directly. So it isn't neglected; it is there. We're also looking, looking at even thermal cameras on the paver. Why not on the roller? You probably have more use of it on the roller than you would on the paver. So a lot of these things now we're looking at the final roller in more detail because he's the one who is nearest the finished product.
Yeah.
Is that what you were on about? What were you meaning?
Yeah. Well, with the drive to take people, entering the site and extra roadworks after doing the testing. I know there's some autonomous ones now, but why double up? Why not take it on site while we're already there?
We got a project running next year where this is part of the project. Actually, we're looking at this. How can we use the final roller to create more information, so we eliminate the need to have a laser measurement afterwards or whatever. Or if you go, I think you use more of the straight edge in the UK, yeah. We tend to have these laser cars running around everywhere, but there are not many of them. They usually come 3 months after the job's finished. Yeah. So
and just another thing I thought of while we're in the presentation, are they asking for safety? Safety applications in pavers in tendering at this tendering stage yet, or
no? that surprises me because I feel sometimes that it's the authorities or the client who should be deciding, or at least leading the way. And I think a big weakness is in the contracts. When you look at the contracts, these things should be itemized basically and priced. Yeah, because we see I remember when I was managing sites, setting out road signs was just something that somebody did in the evening. Now it's a full industry. Now you've got companies who specialize in doing site management, putting signs up, and I got the same feeling. These things, anything to do with safety, we see aspects of the paver, they should be itemized in a bill of quantities. Yeah, so we see that people take it seriously. Because I feel that, yeah.
Well, it will make sense, and then it takes it out of the final pricing schedule, doesn't it?
Yeah. Yeah, you should be able to see it, because then you can also see the serious companies who take it seriously, because you should have an idea yourself what safety costs. Then okay, you need to discuss more than this, but I feel it should be taken much more seriously in the tendering process, in the bill of quantities. It should be seen that it is an item that you look at. Yeah.
Okay. I think we've got a couple on chat, haven't we, Lyle?
Yeah,
I saw one guy. Yeah.
Yeah, sorry, you can probably see them, Martyn, but Gary has asked one which was probably partly dealt with, is when do you think autonomous machines will become the norm in the quarrying industry? And his follow-up question was, why did productivity increase on the remotely operated machines?
The second question is, I have to be honest, I don't know. The only thing I can see is that the guy had a much more comfortable environment. He was more in control of his own environment. I can mail you an answer. So if you want to, I'll get an answer to that. I'll put the question in Volvo. Yeah. And the other question, what was the first question? You was
when do you think autonomous machines will become normal in quarrying?
I think, really, they're already there. We did a job in Africa, not on a high level, but we did a job we sold a paver in Africa 1-2 years ago. And Sandvik were running fully automated loaders down there. And we had a big, we were involved in even the design of the pavement with some special materials. And a lot of discussions about introducing wandering into the autonomous machines, because they were plus minus a couple of centimeters the way they were driving, of destroying the pavement. So we introduced like a 1 meter wandering cycle. But this was Sandvik. But from our side, I think it all comes down to safety. I think that's the big problem all the time. I can't say I'm fully involved in all the quarrying equipment, but machines can run autonomously now without any big issue, but you've got to set up a safety net around it. So if anybody wanders into the area, it has to be able to stop. And I saw that was a big thing with the mine in Africa, that these Sandvik, they were running, but they had a double safety. Once you crossed the first safety barrier, the machine stopped completely. The whole process stopped. This was like 700 meters down underground, and they had I can't really say much more on that. It's outside my area at the moment. I'm seeing more compaction and asphalt. But I think, again, the first machines we'll see in the whole industry, whether it be soil compactors, asphalt, it'll be compactors somehow, because it's definitely asphalt compactors, because they're working as a slave to another machine, basically. So they'll be easy. And the only thing to work out now is the safety, how to ensure that they are safe, because we can't just have machines stopping in the middle of an asphalt job because they think because somebody came into the area. We have to be able to have the intelligence in the machine to understand what is happening. And I think that's where we're lacking, because if you stop a roller, everything stops in the middle of a paving job. It'll be a catastrophe. So we have to be able to manage all these situations. But I think pavers are a lot further off. I think pavers are much further, and the same with electrification of pavers as well. I think, all these things, we're a lot further in the future with those kind of things. Yeah, there are ways of managing it, but the energy needs are so huge that there's no easy way. I think we'll be waiting for the other vehicles to get established first.
Thanks, Martyn. That was really fascinating. Okay. I enjoyed it thoroughly.
Good, I hope so.